All right, guys, we're going to be talking about area of circles today, and I'm not really sure how good our background knowledge is on what is area. So I know you've worked with it in 5th and 6th grade, but I'm not sure how deeply we understand it. So let's take a look at this. I'm going to show you basically what area is. If you pay attention to this, you should have some background knowledge, and then the area of a circle lesson should not be a big deal. So let's take a look. We have a rectangle here. And I can quickly shade it in to make sure you're looking at the same rectangle I am. Looking at this one. And we have to give it some dimensions if it's going to have area, because right now, yeah, it's on my computer screen, but you don't know how long the sides are. They could be inches, they could be miles, so we have to give it some scale. And so I'm going to say that this is 5 centimeters in width and 10 centimeters in length. So now the rectangle has a length and a width. Most people know, coming into 7th grade, and I know you guys do because we've talked about it, is that to find area of a rectangle, it's length times width. So we take our length of 10 and our width of 5, and 10 times 5 is 50. And so some of my 7th graders will say 50. 50 is the answer. Some will say 50 centimeters, and neither one of those is correct. The answer is 50 square centimeters. So we need centimeters with that power of 2 next to it. 50 square centimeters. And so why is that? I'm going to show you why. Down here, I have created 1 square centimeter. What that means is it's a square, and its dimensions are 1 centimeter by 1 centimeter. And so if this rectangle is truly 50 square centimeters, then 50 of these little boxes here, change my color again, theoretically 50 of these should fit over the top of this green rectangle. So I'm going to pause the video, I'm going to break it up for you, and I'm going to prove that, and then we're going to talk about why we would use area. Okay, that should have happened in what was a split second for you guys. Took me a little while to fill it in. But as you can see now, we have 1 square centimeter here, and we had determined the area of this rectangle is 50 square centimeters. And now you could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5. That gives us a grand total of 50. So that's area. It is covering a 2-dimensional shape in square units. So how many square units does it take to cover a shape? In this case, it's 50. And those squares fit real nicely inside of a rectangle. You can see how 50 of them fit just perfectly. What happens when we have a shape like a circle and we're trying to make square units fit inside of that? Let's take a look. All right, I'll try to keep this short so that you guys can try some, but now we have a circle instead of a rectangle. And if we ask what area is, it means the same thing. How many of these square units, in this case they're centimeters, how many of those would it take to cover this shape? Okay, and you can probably see what's going to be an obvious problem. When you start to put squares inside of a circle, when you get to the edge, it's not going to work too well. So I'll draw some lines through this circle so we can kind of get an idea of how many squares it would be, but then I'm going to show you a formula that makes it easy. Alright, so I've taken my ruler and drawn as many square centimeters over the top of this circle as possible. And as you can see, when you get out to the edges, like right here, we have just pieces of squares, and they're not half squares, they're not quarter squares, they're just, sections that we're going to have a really hard time determining what fraction they are. So I can get an estimation here. Let me count up the squares in a quarter of this circle. So roughly in a quarter of the circle. So let's count up a quarter of the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 18. And then I have some that are kind of like half squares, so I might count these as halves. 1 half, 1, 1 half, 1. So there was 2 more there. And then a couple little scraps here around the corner, so maybe 1 more. I'm going to guess about 21. And that was about 1/4 of the circle. So if I multiply that by 4, my guess is going to be about 84 square centimeters. Delete all this. So my estimation is 84 square centimeters. Counted a quarter of them, multiplied it by 4. This is definitely not going to be exact, or I will be shocked if it is. When we're finding an area of a circle, since those square units don't fit very well, we have a formula. And anytime you find the area of a circle, the formula is this. Area equals pi times radius squared, radius to the 2nd power. So I'm going to find a radius here, the distance from the center to the outside of my circle, and then we'll plug it in. All right, so I drew a red radius on my circle, and that radius looks to be about 4.5 units long. 1, 2, 3, 4 full boxes and a half. So my radius is 4.5. Sorry to give you a decimal to start, but that's okay. We're using calculators. So my radius is 4.5. I want that squared. And then we're going to multiply by pi. Remember, we're going to use 3.14 for pi. So now if you have your calculator, this is going to be a piece of cake. Pull mine up. 4.5 squared is what we're going to do first, because exponents go first. That is 20.25. And we're going to multiply that by pi by 3.14. Keeping in mind my estimate was 84. And our actual answer is going to be 63.585. So a lot of the times we'll probably round this number to the nearest whole. So we're going to round it to the ones place. And our area, this is the exact answer. I'm going to round it to 64. And so there are 64 square centimeters within this circle. go ahead and give you guys one to try, and then we'll wrap up this video. So the formula is area equals pi times radius squared. This won't take as long. We're not going to draw the grid over the top. Alright, so if we get a circle, I'm going to tell you that the radius of this circle is 12 inches, and I ask you to find the area. And round your number to the nearest whole, or in other words, to the ones place. Go ahead and pause the video. Give it a try. Alright, here we go. So area equals pi times radius squared. Replace the pi symbol with 3.14. We've got a radius of 12, and we need to square it. We need to take it to the second power. So we do that first. Exponents are always first. 12 squared is 144 times 3.14. And you'll see why we didn't draw the squares over the top. For one, this is not drawn to scale. This is not actually 12 inches, so it wouldn't work anyway. But if we drew one that was a 12-inch radius and we drew all the squares over the top, you're going to see that there'd be quite a few. 3.14 times 144 is going to give us an area of 452.16. We're going to round that to the nearest whole number, so 452 square inches to cover that circle if it were drawn to scale.